All right, guys, we are continuing on with our circle learning. We are on page 5. We are working on arcs and chords. We still have a few vocabulary words to go through, some definitions. We have our first one is central angle, and it is an angle whose vertex is on the center of the circle. So I'm going to outline central angle in purple. And this is our central angle in our diagram. Boy, dog, cat, angle. Boy, dog, cat is a central angle. Its vertex is at the center. We are told that the measure of that angle is 35 degrees. Okay. Next we have the arc, and we talked about this a little bit. It is a piece of the circumference of the circle, and I call it the crust. A minor arc is an arc that is less than half the circle. We name it using 2 points, and it equals the measure of its central angle. So minor arc, why don't I do that in blue? BC is that minor arc, and its measure matches its central angle. Named with 2 points, arc BC, and we're always going the shortest distance between 2 points. Right? I am not going the long way around for BC. I'm going the shortest distance between arc BC. And we also write that as from B to C on the edge of that crust. So we're making an arc or a little rainbow kind of curve on top of BC. So our next one is a semicircle. I'm going to draw a circle. And a semicircle is half of the circle. I'll write that down. It is also named by 2 points, and it is 180 degrees. So underline semicircle in pink, and it is from diameter point to diameter point. Remember, that straight angle is 180 degrees. That arc is also going to be 180 degrees. Central angle, same as arc. Central angle, same as arc. Okay. But it's also named by 2 points from C to H. It doesn't matter if I go northbound or from C to H southbound, because it's 180 degrees. It doesn't matter which way I go, because they're both the same. Okay. All right. Our next one is our major arc, and that is more than half the circle. This one is named by 3 points because it's going to give you directions. Okay. I'm making a circle with a center, and let's call you point D, O, G. And I want to know about arc DOG. So I'm going to go start at D, go through O, and end at G. That is a major arc, and so we would name that DOG with the umbrella. And my apologies, guys, we'll need to go back to semicircle, and we're calling this arc CH. And that is the way we name and identify arcs and their measures, given we have the central angle. So some more theorems that we can use are the fact that congruent central angles have congruent chords. Well, what does that mean? Okay. If I have a central angle, the same as this central angle, then the chord that it opens up to and the chord that the other one opens up to are going to be congruent. Okay. That's pretty handy because if I know that this is 5 units, then I can automatically say that this is 5 units. Samesies, all I have to do is data copy. Our next theorem is that congruent chords have congruent arcs. So if this chord is congruent to this chord, then this arc is going to be congruent to this arc, okay? Which is going to also create congruent central angles. Okay? So they kind of a 3-step. Central chord arc, all of these guys are the same when we have the same arc measure, the same chord length, or the same angle measure. Well, that leads us into our next theorem, that congruent arcs have congruent central angles. So if this arc is congruent to this arc, then this angle is congruent to that angle. Get a lot of the samesies going across here. Makes things pretty easy to work with if we have just one number, and we can just data transfer a lot of that stuff around. Our next theorem is that if a radius or a diameter from the center to the edge, or from edge to edge through the center, if it makes a right angle with a chord, then it cuts the chord and its arc in half. So if this is our radius, we have a bisected chord cut in half, and if this chord opens up to this angle or arc, then that arc is congruent to that arc. So again, we get a lot of the samesies happening when we have these bisectors. So let's take a look at an example. If you're a little unclear, I can understand that. So let's get a little clarity. Okay. First, I am asked to find the measure of arc AC. Measure of arc AC here in pink. My central angle is 75 from the central angle theorem. We also know that that arc measure, is 75 degrees. Well, that didn't come off. All right. 75 degrees. Sorry about my handwriting, y'all. All right. Next, we are to find the measure of CY. So from C to Y, the shortest distance. Well, I don't have its central angle, but can I figure it out? AY is a diameter. It goes from edge to edge through that center point. I know that a diameter, a straight angle of 180 degrees, opens up to an arc of 180 degrees. So arc AY is 180. I know about 75 of it. So 180 degrees minus 75 degrees is going to give me 105 degrees. That is the measure of the arc from C to Y. So I should probably write that in. Grab my pink and write in 75 degrees up here. All right, I'm grabbing my purple. Now I'm asked to find the measure of arc AYC. Start at A, go through Y, end at C. Start at A, go through Y, end at C. Okay. I gotta figure this one out. Oh, all right, let's look. So from A around to Y is 180. So I know about that. 180 degrees. From Y to C, I figured out is 105. So I'm going to add those two together. Have I gotten it all? 180, 105. Excellent. Then I get a total of 285 degrees. And that is the measure of arc AYC. Okay, I have turned the page. We are now on page 6. So let's do a few example problems. Okay. Number 4, RS, or line segment RS, is congruent to line segment TU. So RS is congruent to TU. All right. I need to find the measure of arc RS. And I'm given 3x as its current measure. And I am given 2x plus 27 as the arc UT's measure. Now from my learning today, I learned that congruent chords make congruent arcs. So I'm going to set those equal to each other and solve that algebra problem. 3x equals 2x plus 27. X equals 27. But I'm not done yet because I was asked to find the measure of RS. So now I'm going to say that RS equals 3 times 27. And that gives me a total of 81 units. Oh, Ms. Hart, you just make it worse. 81 units. That is the measure of, oh, I'm sorry, 81 degrees, guys. Sorry, 81 degrees. Oh, Ms. Hart, Ms. Hart, Ms. Hart. 81 degrees. It says degrees here, it says degrees here. I don't know how I missed it. 81 degrees. Very common mistake. And I made it, but I fixed it, so I'm happy now. Number 5, we are to find BD. So from B to D, I am to find the length of that chord. And what information do I have? I have from A to E, from the center to the edge. That's my radius. 5, take a break 2, so my radius is 5. And I've got a drawing that looks like this, where this is 2, this is 3. I'm trying to find either side, but I am going to draw in a hypotenuse. Maybe I can draw it in a little better. There we go. Which is basically adding AD, also from the center to the edge. That's a radius. That's by definition a radius. So I'm going to data transfer the fact that this drawn in hypotenuse is 5. That gives me a right triangle here of 3, 5, and unknown x. Here is my right angle. Okay, so I have copied triangle ACD, and I am about to find the distance between D and C. 3 is a leg, so 3 squared, plus my unknown leg, CD, x squared, equals my hypotenuse of 5 squared. So 9 plus x squared equals 25. X squared equals 16. Take the square root of both sides. And my answer for the length of C to D is 4. Now, that radius intersecting a chord at a right angle creates samesies. That radius is a bisector, cut in half. Therefore, boy cat is 4, just as cat dog is 4. So I walk all the way across that chord. I have gone 8 units. I have a very similar setup with number 6. And I'm going to do the same thing. Maybe this time I'll make it a little bigger. I've got a side of 9, 8, unknown, right angle. And I am asked to find NP, the length of that chord again. So the length of my radius is 17. Okay. Now, point R down here to point P, also drawing that. That radius is 17. From the center to the edge, I'm going to make that hypotenuse 17. Exact same problem. 8 squared plus x squared equals 17 squared. Still making it worse, Miss Hart. 8 squared plus x squared equals 17 squared. So 64 plus x squared equals, I don't know what 17 squared is. I'm going to go to my calculator. Get 289. So x squared equals 289 minus 64, 225. Taking the square root of both sides. And I get 15. X equals 15. Now, I'm not done, guys, because remember, this is the part I found. So if this side is 15, and I know that this right angle with my radius and my chord creates a bisector, then this side is also 15. So a walk all the way from Nancy to Paul is going to be 30 units. And that is my final answer for number 6.